Okay, let's unpack this. Today, we are diving deep into a really interesting intersection. Large language models, or LLMs, meeting front-end development, specifically within the React ecosystem.
Yeah.
This is a space that's moving incredibly fast, and we've pulled together a stack of sources to help us, get a handle on it.
Exactly. We've got an article from Anima detailing how they're using LLMs to enhance code generation, a guide on how to integrate LLMs into your React applications using a library called useLM,
Right.
and a helpful list of various relevant React libraries cropping up in this space.
So our mission is to walk through these sources, understand the different ways LLMs are being applied with and in React, pull out the key insights, and give you some practical examples you can wrap your head around. Think of this as a snapshot of how developers are starting to leverage this powerful technology in the front-end world.
It really is a rapidly evolving landscape, and seeing these distinct approaches gives us a good perspective on the current state and, well, the future potential.
Absolutely. So let's start with the first source, the piece from Anima. They've been in the code generation game for a while now, right? 6 years, they mentioned.
That's right. They have a solid background in generating code, which is, I think, key to understanding their approach here.
Yeah.
They aren't just starting from scratch with LLMs. They're integrating them into an established process.
And their core process, as described, starts with a design file, like a Figma file. Anima first generates the React code directly from that design, focusing on making sure it looks exactly like the visual layout in the browser. High fidelity is the initial goal.
Yes, and here's where the LLM layer comes in. They don't use the LLM for that initial visual code generation. After the base visual code is generated, they use LLMs to enhance it.
That feels counterintuitive at first glance, doesn't it? Why not just ask the LLM to do everything up front?
Well, what's fascinating here is their explanation of why this layered approach works well with LLMs. The source explicitly states that asking LLMs to do too many complex things at once degrades the results exponentially. Trying to go from a web page snapshot to a full app with all the features, they say, will likely lead to frustration. This tells us something important about where LLMs currently excel in this domain.
So they're saying LLMs are better at focused, perhaps more constrained tasks, especially when working with existing code.
Precisely. Asking them to add a little bit of code to existing code or perform tasks where there are massive amounts of examples is straightforward and effective, according to their experience.
Right.
They leverage the LLM's strength for these specific, well-documented patterns and tasks. This is the key insight from Anima. LLMs as powerful augmentative tools applied strategically after initial generation.
This is where the examples come in, showing how prompts add specific layers of functionality on top of that base code, like localization, for instance.
Yes, localization is a great example. The LLM can convert hard-coded text into dynamic localized copy. They show how a simple prompt like add localization to the button can transform a component to use keys from something like n.json and es.json.
And their reason for the LLM being good at this is insightful because there are a lot of examples, tutorials, and documentation out there for localization that the model has been trained on. It's a well-understood code pattern.
Exactly. It's not inventing localization. It's applying a common pattern based on vast training data.
Makes sense.
The same principle applies to accessibility. A prompt like add accessibility features can enhance components by adding attributes like area label, as shown in the source. Again, a well-documented pattern.
And tracking. They mention adding event tracking, specifically Google Tag Manager, GTM tracking, with a prompt like add event tracking with Google Tag Manager. The LLM knows the standard code snippets and patterns for this and can inject them where needed.
So the big takeaway from the Anima source is the strategy of using LLMs to add these specific layers: localization, accessibility, tracking on top of the already generated visual code. It plays to the LLM's strength for focused enhancements on existing code, rather than attempting complex greenfield generation. It frames the problem in a way LLMs are currently capable of solving reliably in a developer workflow.
Okay, that's one way LLMs are intersecting with React as a tool to enhance the developer's workflow and generated code. Now let's transition to a completely different angle presented in our second source, the Use LLM guide. This is about integrating LLMs into the React application itself.
This shifts from using LLMs to help developers write code to building applications where the LLM is a component of the application's functionality.
Okay.
Your React app interacts directly with an LLM API to generate content or responses dynamically for the user within the app. Think interactive AI features, not just generated static code.
Got it. The USLM library provides a practical example of how you might start to do this. The guide walks through the basic steps involved.
Right. First, you'd add the library to your project, typically using a package manager like npm install usl. Simple enough.
Then, in your React component, you need to bring in the functionality provided by the library. This often involves importing a hook, which is a standard React pattern,
Yep.
for letting functional components manage state and side effects.
Yeah.
Import uslm from usil.
And then you set up that hook, configuring it. This usually involves specifying the LLM provider you're using, like OpenAI, giving it your API key so it can make calls,
Crucial.
and selecting the specific engine or model you want to interact with. You'll also typically use React's useState hook to manage the response you get back from the LLM and track if the request is still loading.
Right, the loading state is important. So, to make the call to the LLM, you'd use a method provided by the hook, perhaps something like lmm.chat, and you pass in the prompt. The guide gives an example prompt, like, write a poem about user input, showing how you can use input from the user within your app to dynamically construct what you ask the LLM.
And handling the response involves processing the data you get back from the LLM API, accessing the actual text generated by the model, and then updating your component state to display that text in your application's user interface.
This all ties into the UI, right? You'd have a button or an input field that triggers a function. That function would set a loading state, make the call to the LLM API via the hook, and then update the state to show the generated response or a loading message or perhaps an error if something goes wrong.
Exactly. And the guide adds some crucial reminders here. You absolutely need an API key to use the LLM service, and you should explore different providers and models.
Good point.
As they have different capabilities and costs. It also points out that for production apps, especially those handling sensitive keys or managing complex state and rate limits, you might need a back-end server to handle the actual API calls to the LLM rather than making them directly from your front-end code.
Okay, that makes sense. You wouldn't want your API key exposed in the user's browser.
Exactly. So this source gives us a clear path for building React apps that are LLM-powered, where the application itself initiates the interaction with the LLM to provide dynamic features like text generation or conversational responses directly for the end user.
Right.
It shifts LLMs from a developer tool to an end-user feature.
Okay, so we've seen using LLMs for code generation enhancement and building applications that use LLMs. Our final source gives us a glimpse into the growing ecosystem of specialized tools for that second scenario, building LLM-integrated React applications that serve the end user.
This list of libraries shows that developers are creating specific tools to tackle common challenges and use cases when incorporating LLMs into the front-end user experience.
Right.
Building these dynamic, AI-powered interfaces presents its own set of problems.
Let's look at what some of these libraries aim to solve. One area seems to be handling the output itself. There's LMIA.
LMIA focuses on rendering the text output from an LLM cleanly in the UI. LLMs can sometimes output broken markdown or text that needs formatting,
Yeah, I've seen that.
This library helps with that and is headless, meaning it provides the underlying logic and structure for displaying the content, but lets you fully control the styling with your own CSS.
Okay. And flow token is also mentioned in relation to output presentation.
Right. Flow token aims to improve the visual presentation as text is streaming back from an LLM.
Ah, the streaming part.
Yeah, it provides animations to make the text appear more smoothly as it arrives, which can improve the user experience while they're waiting for the full response. Kind of neat.
Beyond just display, some libraries focus on where the model runs. React is interesting because it lets you run LLMs directly in the browser,
which is a significant capability. This means potentially running models client-side using technologies like WebAssembly, loading and caching the model files locally or from a CDN.
Wow.
This can have implications for privacy, latency, and even enabling offline use cases.
And React Native AI takes that concept to mobile.
Exactly. It enables LLM execution on mobile devices within React Native applications, powered by an engine like the MLC LLM engine. This opens up possibilities for on-device AI features in mobile apps without needing a constant internet connection or relying on a back-end server for every LLM call.
And finally, if you're building a specific type of LLM interface, like a conversational one, libraries like Inlux come into play.
Unlux is designed specifically for building conversational AI interfaces, providing components and features like theming and localization tailored for chat-style interactions.
Gotcha.
This streamlines the process of creating a polished chat UI that leverages an LLM backend.
So this list really underscores that if you're building an application that uses LLMs for the end user, there are specialized tools emerging for specific tasks.
Definitely.
From displaying the text elegantly to running the model right there in the user's browser or on their phone, or building a full conversational UI. The ecosystem is rapidly evolving to support these needs.
It shows that as developers explore integrating LLMs into front-end apps, common patterns and challenges are emerging, leading to specialized libraries to address them efficiently.
Okay, let's connect the dots on what we've covered. We looked at two main angles. Using LLMs to make the developer's life easier by enhancing generated or existing code, and building applications that directly integrate and interact with LLMs to provide dynamic AI-powered features for the end user.
The common thread is that LLMs are becoming increasingly relevant across the front-end stack, whether as powerful tools augmenting the development workflow or as core components within the user experience itself.
Right.
They are changing how we think about building interfaces and features.
Understanding these different approaches, enhancing generated code versus building LLM-powered features into the app, gives you a clearer picture of the possibilities and the kinds of tools that are available or emerging in this space.
Yeah.
It's not just one narrow application, it's a spectrum of ways LLMs can impact or be used in front-end development.
Exactly. It highlights their versatility, but also suggests that their strengths might lie in different areas depending on whether they are augmenting the developer or empowering the user directly.
So let's wrap this deep dive up by summarizing the key takeaways. We've seen how LLMs can add specific, well-defined features, like localization or accessibility to generated code by layering them on top, playing to their strength and applying known patterns based on vast training data.
And how libraries like useLM enable integrating LLM capabilities directly into React applications, allowing the app to make calls and use LLM output dynamically to create interactive AI-driven features for the end user.
Plus, we saw a glimpse of the specialized tools available for building those LLM-integrated apps, covering everything from displaying the streaming output smoothly to the fascinating possibility of running LLM models right there in the user's browser or on their mobile device.
Yeah, that's pretty cool.
And libraries specifically for building conversational interfaces.
All based on the source material we explored today, giving us a snapshot of this rapidly evolving space.
Which leaves us with a final provocative thought for you to consider. Given what these sources show, LLMs excelling at adding specific layers or features to existing code for developers and powering targeted, often text-based interactions within apps for users, what does this imply about the primary future role of LLMs in front-end development? Are they poised to remain powerful, specialized tools that largely augment developers' existing workflows and traditional interfaces, or are they truly on the verge of becoming fundamental, perhaps even visual building blocks for entirely new paradigms of user interfaces and experiences that we haven't even fully imagined yet?